What?
There's something bigger than
At this time, we need students in the following clubs to come down to the multi-purpose building for pictures. Beta Club members, National Honor Society members, and student council members, and sponsors. Thank you.
Titanosaurus.
Man, that's just scary though.
We're just gonna keep moving along.
Okay, so we're looking here. Shh, y'all be quiet. We're looking here at division today. We're going to look at two separate methods for division. The first that we're going to do is long division. Oh, I forgot a parenthesis up there after two. Long division, and you've done long division in elementary school with just numbers, but now it gets even more fun because they've got variables and exponents in them. Woohoo! So we'll look at long division like that. And then we're going to learn a new method called synthetic division. Now, synthetic division is way easier. So then why do we got to do this harder way? Because synthetic division doesn't work every time. This long division will work every time. Synthetic division only works part of the time. So we're going to set this up, and I'm not sure I'll be able to use the tablet the whole time because sometimes these take up a lot of room. But we're going to set this up. Remember what you're dividing by, this polynomial over here on the right side of the division sign. That's what goes outside of your box. So this is remember what we're dealing with when we do long division. Now, before I put the first polynomial inside of the box, I got to notice something about the degree. My degree here's 4. We talked about that already. Whatever your degree is, when you put that polynomial inside the box, you got to have every power underneath that. So I've got 4, 3. There's no 2. There's no second power. So I'm going to have to put a 0 in that place when I put it under the box. So we're going to write that as 2x to the 4th plus 3x cubed plus 0x squared plus 5x minus 1. And it's the same thing out here also. If you're missing one of the powers out here, you also got to put a 0. But we weren't missing it, so didn't have to. All right. Now this whole shebang with long division starts by taking the first term outside the box and seeing how many times it will go into the first term inside the box. So I got to figure out right now what we're asking ourselves is what can I multiply x squared by that would make it turn in to 2x to the 4th. We should know it's got to have a 2, right? To go from a 1 to a 2, you got to have a 2, right? And I got to go from an x squared to an x to the 4th. So x squared times what would make x to the 4th? CJ's right, it's x squared, right? So I'm going to put 2x squared up here on my roof. Okay, what we did to get that again is this number times what will get me that number. Okay, so it's whatever we multiply this one by to get that one. So now once you figure that out, you're going to take that number and you got to distribute it to all 3 of these and it'll line up underneath here. So we got to do 2x squared times x squared. That should get you 2x to the 4th. Remember, that was the whole point. We were trying to get that same thing. So 2x squared times x squared, 2x to the 4th. Now we go to the next one. What's 2x squared times 3x? Close. 2x squared times 3x. 6x to the 3rd. Because you got a 1 and a 2. So 6x to the 3rd. And notice they're going to line up under, oops, I wrote 63 like a doofus. They're going to line up underneath their like terms. Okay, now we haven't done the 2 yet. So 2x squared times 2. Bless you.
Thank you.
No. 2x squared times 2. 4x squared.
But I thought you couldn't combine those because they're not like terms.
You can multiply and divide. It's add and subtract you can't do. Okay, so now we've done the 2x squared times all three of those. So just like in elementary school, after you do all that, you draw your line and subtract. Okay? So look what happens here. 2x to the fourth minus 2x to the fourth, that's nothing. He gone. 3x cubed minus 6x cubed.
Negative 3x cubed.
Negative 3x cubed. 0x squared minus 4x squared.
4x squared.
Negative 4x squared. Then do you remember what you did after that? Has to do with this number.
Bring it down.
Good, CJ. We dropped that plus 5x on down. Okay, so that's phase one.
Yeah.
You had minus 1.
Not yet. You only bring one down at a time. Good question. But only bring one down at a time. Your rule for this is you always need to have as many down here as you do out here. So we got 3 and 3, so we're good. Now that was phase one. We start that whole phase over again, but now we use our new numbers down there. So x squared times what makes that? Just like we did up here, now we're using that one. So let me highlight that one for you so you'll... Okay, I got to figure out x squared times what makes negative 3x cubed, and Grant's got you started off with a negative 3, so I'm going to put that up here on the roof. What else does it have to be to go from an x squared to an x cubed? What can I multiply by that changes it from an x squared to an x cubed?
1.
1 what? To go from an x squared to an x cubed. No. It's an x, right? Because it's x squared. So x squared times x makes x cubed. So with that negative 3 you figured out, also need to have an x there. Now notice what happens up here, because this is going to be hints for you. Started off at x squared and now it's an x. So it's going down descending order, yes. Okay, so now, last time we took 2x squared and multiplied it times all three of those.
Now we're going to do 3x squared.
So we're going to do negative 3x now times all three of those.
Negative 3x.
Okay, so negative 3x times x squared is negative 3x cubed. And remember, that's always the point. That first time you're trying to always get the same thing, so it cancels out. Now we got negative 3x times 3x
Negative 9x
squared.
Negative 9x squared.
And then you got negative 3x times 2. Very good. And then draw your line and subtract.
If that cancel, then it'd be...
Oops, that jumped a lot. Okay, so Grant said that cancels.
And then you add...
Negative
so
4 minus negative 9, so that's 5x squared. He's right.
And then you have...
5x minus negative 6x is positive 11x. Good. Now you've got 2 pieces down here, but you've got 3 out here. Good, CJ and Grant. We got one more thing we can drop down, so bring negative 1 all the way down here to the party. That was phase 2. Now we got to do it all again. We got to figure out x squared times what would make 5x squared.
X times 5 because it's 1.
Good. So we're going to multiply it by 5. So we put a plus 5 since it's positive up there on the roof. And so now look at what you're right, but look at what you got up here. Squared first, nothing. So that still went in descending order. So now take your 5 and distribute it to all 3 of those.
So would it be 5 times x? Would it be x squared?
5x squared, yep. 5x squared. And then you got 5 times 3x. I had a kid. And then you got 5 times 2. Plus 10. Draw your line and subtract. Yes, CJ said the 5x squareds cancel out. 11x minus... Say that again? Oh, I thought you were talking to me. 11x minus 15x.
11x minus 15x. That'd be negative 4.
X. And then negative 1 minus 10.
That'd be negative 9.
Negative 11.
Negative 11. Okay.
Okay, that's all right. Now, I got 2 things down here, and I got 3 out here. I told you you needed to have the same number of them. If there's nothing else to drop down, that's when it tells you you're done. So when you were a little...
-4x.
No, hold on. When you were a little tot, this was started with an R, what this was called. Do you remember when you divided and you had something left over? And it started with an R? The leftover was a big hint.
Remainder.
Yes, very good. And then when you were a little tot, it was real nice. You got to write like 2R4. Remember that? You don't get to do that anymore. To write your answer, because that's what you need. That's what Grant was asking about. To write your answer, you take what you got on the top.
Put it out and then write.
So we would have 2x squared minus 3x plus 5 plus your remainder.
So you draw a line under your remainder.
Oh, your remainder over what you divided by.
Oh, okay.
So that would be your final answer. This was the remainder, and this was what was outside our box, what we divided by.
That didn't take long.
The little kids are outside.
One problem, half of your paper.
Little kids are
Well, I went from writing in a decent size to writing.
outside. They come to every class.
No, they don't come to every class.
Oh, they don't? Oh.
Some of us Scrooges don't have them come in here.
You don't give out candy for them?
Why?
I don't know.
Bad for the
She
teeth.
don't believe in candy.
That's so mean.
I don't believe in candy.
Your bus riders are going to ask you why we didn't see you today.
One of the kids the other day in kindergarten said, "Do you have another car?" So they think that you just drive that bus. And I said, "Yeah, I have a truck." "Well, where is it?" And I said, "Well, it's down where I parked the bus." "You parked the bus somewhere?" "Yeah. Just drive this Kroger every
Yeah, I was gonna say, he's probably used to like other schools because like Poland, all the bus drivers take
Some of
buses
them
home.
do, yeah.
Yeah, there's always a bus on the side of the road
for the parking at school.
Yeah.
going toward Sheridan.
Where I live is in the Glenrose district, and the bus goes right by my house. And when I used to teach at Glenrose, I always thought, well, I could just drive that route and just drive the bus home. But I never did.
Yeah, that's
You drove a bus at Glenrose?
Grant, the one that you're talking about, I know the lady. She was
Why
my
do you
driver
drive
for
a
like
bus?
6 years. I know the lady very well.
Yeah.
Miss Beverly is her name. Sweetest woman I've ever met. The bus driver, like when you go to Poland and then you're heading towards Sheridan, you pass by that one house that's got the bus. I know the lady who has that bus.
Are you giving out candy on your bus?
No.
Go
Are
leave them.
you nuts?
Yeah, then she'd have to pick
The
it all
two
up.
worst days for a bus driver are the day after Halloween and the day after Valentine's. I couldn't think of it. Yes, those are miserable.
No, you give it as they're walking off. So then
Well, that's not what happens over there in the elementary school. Those teachers load them up with candy and then shove them on the bus.
Do they go to the middle school too?
I don't know.
I mean, that's crazy. That's like enough candy.
Yeah, that's it's not fun having to keep those things up.
Alright, this one, we'll just do this one more and then call it a day since y'all have been so good. This one I'm going to do another way. You could still do this one the long division way that we just did, but I want to teach you an easier way. And I'll show you why this one will not work every time also. Go ahead, Maddie.
Are they all the same?
No, the way I'm going to show you this one is faster and easier.
But you
But
can
you
always
can't
do it?
do it.
Correct.
Okay.
And here's, let me go ahead and say why.
Does that say A or not?
9. On the last one, we divided by something that was squared. Remember, we divided by this right here, x squared plus 3x plus 2. If you divide by something that is bigger than the first power, you have to do long division. But right now, we're dividing by just an x minus 3. That's the first power, x to the first power. So there's a shorter way. So anytime you're just dividing by an x to the first power, not anything squared or cubed, there's a shorter way. It's called synthetic division, and it takes the letters completely out of it. Okay, we only have numbers. Can y'all believe that? So what you're going to do to start, your box is upside down. This is called synthetic division. I think that's how you spell synthetic. Inside the box, you're going to only put your coefficients in descending order. Okay, so how many x cubes do I have? What's the coefficient on x cubed?
1.
Close.
-1?
-1. Leave a little space underneath. I got to
So
put
then
something
you have-
underneath here in a minute.
Then you have 4.
Then x squared, I got 4. Leave a little space. No. What about x to the first? How many x to the firsts do I have?
2.
3, 2.
Zero.
Good. I don't have an x up there, so I've got a 0 for it. And then my constant is 9. Okay, now, outside the box, what you're going to do is take what you're dividing by. So you're going to take that x minus 3, and you're going to set that equal to 0 and solve. So 3 is what's going to go outside my box.
On the side or underneath?
On the side. Ooh. 3. Everybody, we took this and set it equal to 0 and solved. Now sometimes you'll get a real friendly problem and it will just say x equals 3. So then you'll just put the 3. You won't have to do that solving step. But if it's written as a factor like this, you got to solve it. All right. So to start the show of synthetic division, every time you drop your first number all the way down outside the box. This is new, but it's way easier. All you do from there, multiply, add until you get to the end. So you take what's outside the box and multiply. -1 times 3. And you put it in the next space. So -1 times 3 is what? -3. So it's going to go in that next empty hole that I have there. Okay, now you add. So what do you get when you add right here? 1. Then you're ready to multiply, because it's just multiply, add. So now I multiply this new answer times the 3.
So it'd be 3.
It goes in the next spot, and then I add.
3.
Multiply.
9. 18.
Okay, so you're done. Way shorter, way faster, but that doesn't look anything like this kind of answer. No. So I got to be able to make this look like some kind of answer like this. We started with an x cubed and divided by an x. So my answer here has got to be 1 power less than that. See right here? Well, I didn't write it all down. But on the last one, we started with an x to the 4th and divided by an x squared. So that 4 minus 2 made our answer be 2. So here, 3 minus 1 makes our answer here be a squared. Whatever you start with, your answer is always 1 power less than that. And these are your coefficients. So my x squared is -1x squared. And then I'm just going in descending order from there. Plus 1x, 2, 1. So what's the 3? Just set it back there. I'm busy right now. What's the 3? 2, 1. What's the 3? I got a squared. I got a first power. What happens after first power? What happened up here after first power?
Oh, it's multiplied.
I got a squared. I got a first power. What is the 3 going to be?
Constant.
Yes, it's just a 3. Very good. So squared first, my nothing. I still got an 18 left there. What could the 18 be?
Could be another constant?
No.
No.
What did we have earlier when we had something left
Remainder.
over? Remainder. So plus
18
my
over
remainder
x3.
over what I
3.
divided by.
So there's your answer.
So there's your answer.
Okay.
New, so a little scary, but way easier than the long division.
I get that.
Way easier. It's just multiply, add, multiply, add, multiply, add. That's all there is to it. Alright, so I told you yesterday what we're leading up to is solving the polynomials. But we can't just jump right into it, so we practiced add, subtract, multiply yesterday. We just practiced a smidgen of divide today. Tomorrow we're going to practice factoring, and we've been factoring already with our quadratics. But we're going to factor tomorrow, and then we're also going to factor a lot next week. Y'all listening? Because factoring is one of the best methods for solving these. So we're going to do some assignments next week and some activities and games next week for factoring. And then we'll get into solving them from there. Everybody all right?
Yes, ma'am.
Everybody's like, no. It's okay. You won't be completely lost. We'll get you caught up.